Okay, so we're going to take a quick look at the if statement here. You've written some if statements, mostly by copying stuff that was there or by editing stuff that you'd already seen. So now we're starting to write our own. To figure out when an if statement is necessary, you want to recognize it's basically any time we're making a decision. In the real world, if I do this, or if this happens, then I react a certain way. Same sort of thing goes on in the program, and that's exactly what we're trying to make the program do. So here here you are sitting in your classroom, just being a good little boy or girl, and you hear an alarm. So what you have to determine is, first of all, is the alarm I'm hearing a fire alarm? If it is, then what you're going to do is head outside, line up on the sidewalk. If you determine that it's not a fire alarm, then you start to think, what else could it be? Well, if it happens to be the school bell and it happens to be 3 o'clock, then I'm going to run outside and wait for my bus. If it turns out that it's not this combination, then you continue to wonder, what would I do then? Or what should I do now? Well, if it's the school bell and it's close to noon, then what I might do is head outside and play. It's a sunny day. We're going to have a good time. Continuing with the same process, if it's not this one, then consider another possibility, which is, in this case, it's just after 10 o'clock, school bell again, which means, oh, it's time for me to go to my next class and be a good little boy or girl and work there. If none of those cases occur, so if I've gone through my thought process, well, what's that alarm? It's not this one. Well, it's not this in combination. It's not this in combination. And it's not this in combination. Then basically, oh, I don't know what it is. I guess I'll just forget about it. Okay. So our little pseudocode here. If the alarm we're hearing, so I guess we could start by saying get, this is not the keyboard that works, get the alarm. Now, if the alarm that we've got, that we've heard, is the fire alarm, head outside and meet on the sidewalk. Else if, so again, assuming this has not occurred, consider this possibility. Is it the school bell and 3 o'clock? If it is, go catch your bus. If neither of these possibilities has occurred, then I consider the possibility that it might be the school bell and noon, time to go play outside. And then again, if none of the other possibilities have occurred, then I can consider the possibility of it being a school bell and time to go to my next class. And if I've determined that none of those are the situation that I'm in right now, then I'm just going to, I guess, ignore it because I don't know anything better to do. Obviously, I could have other options here, but that's sort of what I know. So if we look at an example here, let's see if I can make this nice and big. What I've got is a simple form, 2 buttons on it, and it's pretty simple. I type in a temperature here. Depending on what I type, the button gives me some kind of feedback. Okay. Now, the interesting thing, if I look at the 2 buttons, or look at the code within the 2 buttons, it looks pretty similar. So the first 2 lines, of course, declare a variable as an integer, pull the temperature off the screen, and then if it's less than 50, no school today. Not necessarily an actual rule, but it's sort of a good guideline. Else if the temperature is less than -30, indoor recess. Else if the temperature is less than 0, we get to play in the snow. Else if the temperature is less than 10, I'm leaving my jacket at home. And if it's anything above that, anything else, which would have to be 10 or above, I'm melting. So looking at that code, and then looking at this one, you'll see that all the options are the same. There's the 0, fun in the snow. There's the -30, indoor recess. -50, no school today. Melting is still the else, and else less than 10, leaving jacket at home. What you may have noticed, of course, is that when I punched in a number like -56, I ended up with 2 different responses though. And the same will be true for some other values. And I keep pushing numbers on the keyboard that's not. Okay, so 5, I actually get the same answer. 51, I get the same answer. -1, fun in the snow, fun in the snow. So for again, a lot of these, I'm actually getting the same thing. But we did see that there were some discrepancies depending on which numbers I actually choose. Fun in the snow, indoor recess. And so the important thing to recognize is in the same way that the fire alarm was the first thing that I checked here, and it was the first thing I considered. And if it turns out that the alarm is not the fire alarm, only then do I consider the other options. Okay, so the same thing's true here. In here, the first thing I check is the temperature less than 50? If it is, then I'm going to display this. If it's not, then I consider going on to the next option. Okay, so these ones are in a nice logical order, smallest to largest. The problem with this one, of course, is they're not in that same order. So the very first thing it checks is the temperature less than 0? In this case, anything in the -10, -50, anything below 0 basically shows up as fun in the sun. And so the options here and here are never reached, because anything that's less than -30, of course, is also minus or less than 0. So first thing to note is the order matters. The if statement is the first option. The first else if is the second option, third option, and so on. Else is your fallback. If none of these occurred, then this one will. You don't have to have an else, of course, and you can have as many else ifs as you want. 1, 2, 3, up to 10,586,921. No, actually, you should have more than that. And you can only have one else being the final catch-all. So one if, 0 or 1 else's, and 0 to infinity else ifs. But again, the order matters here. Now, because I messed up the order, I do have another option. One of which, of course, I could rewrite this. The other is, I can't use that keyboard again. I can use an and to limit the upper and lower bounds of my statement here. So here I have if temp is less than 0 and temp is greater than, let's see, -30, is that right? Anything less than -30 we want to show up here. So I guess this should be greater than or equal to -30. So we want to make sure that -30 is not in this realm if we were actually looking to get the same values as we did on the first part. Okay, so just another option. Put and statements in to make multiple conditions be required to get to this point. So if the temperature is less than 0 and it's also greater than or equal to -30, now print fun in the snow. Else if the temperature is less than -30 and it is also greater than or equal to -50, then it's okay to say that it's an indoor recess. If it's less than -50 though, we will get down to the no school today. Oh, sorry, actually that's true, because of course this one gets in the way as well now. Else if the temperature is less than -10 and the temperature is greater than or equal to. Now this one, interestingly, I could put 0, and that seems to be the reasonable thing to put. I could probably also, because anything less than 0 or between -30 and 0 has already been handled, I could actually make this less than -50. There's no good reason to do that, but it would work because the -30 to 0 has been handled here. The -50 to -30 has been handled in here. And so all of those numbers have been handled, and we're just interested in the ones that are less than 10, but still not below -50. Now again, here 0 makes more sense. And now this program will run the same as the previous one did. Okay. So just a final little note on the class website, the if practice. I think I've already mentioned this, so I don't know why I'm bringing it up. Yep, that's not what I meant to bring up. The under notes, PB notes. Some of you may not realize this is here or may have forgotten that it's here. And so just kind of reminding you. It's just a quick reference to the various things we're going to see this year. It actually goes a little bit ahead of where we are right now, but it talks about the input statement, the various input options. It talks about output, and every now and then I throw in a little bit of extra information there in case you happen to miss something or not seen it yet. The ands and ors for comparison with if statements and do loops later on. And means both things have to have happened. The or means either one of them or both can happen. Okay, so you want to be careful and know, do I need both my situations to be true for my statement to run, or do I want a little, one or the other? And then down into the if statements here, there's a few different options showing up. It shows you can make an if statement with just a single, on just a single line if there's only one thing going to happen. If the mark's greater than 89, display this. Otherwise, do nothing. You can do your if statement where it's got various different sections. Look at consider the first option, then consider the second, consider the third, and then the catch-all at the end. You can have an if statement where it considers one thing and does some stuff, but if that condition doesn't hold, then it doesn't do anything. And then, of course, example showing with an or here, if the number is greater than 100 or less than 0, it's not a legitimate mark. Otherwise, go ahead and display the mark. Okay, so just a couple of different things. You can see how you can put an if statement, a complete if statement inside of another if statement. You can have an if statement that starts and ends, followed by another one that starts and ends. You would want this situation if both options were things you wanted to consider. I want the hours to be potentially greater than or equal to 40. And if it is, or whether it is or isn't, I also want to consider what the pay scale value is. Okay. And then, of course, there's quick little explanations down here of each of them, what I was trying to show. General notes, else handles every other case, ensuring something will happen. And an or can be used to make sure the combinations are true. And conditions in ifs will always be evaluated as true or false. Okay, so basically what the computer does is it looks at this and says, hours greater than or equal to 40, that is true. It is. Or no, it is not. Same sort of thing here. It looks at, sorry about that, mark greater than 100, it says true or false. Mark less than or equal to 0, less than 0, true or false. And if either part is true, then it determines it's okay to come into this section. So that's a quick rundown of the if statement. As I said, you've seen some already, so hopefully with this and with some practice, you'll get pretty comfortable with them. Last statement, again, anytime you need to make a decision in your program, anytime you need to make a choice. Sometimes I want this to happen, sometimes I want this to happen, or sometimes I want this to happen and other times I don't want it to happen. That will always be an if statement. And usually if you actually talk it out, if I ask you, what do you want the program to do? You'll actually say the word if. Well, if it happens to be, or if the number's bigger than, or if the guy types in his name wrong, those will all be situations where you'll use the if statement. All right, good luck.